Hi there, Mr. Brewer here with week 6 already of our online stuff. And last week we talked about the geologic time as far as how they came up with the time scale, um, being relative time dating, and then adding in what we now know about absolute time and radiometric dating. This week we want to look at just what is that time scale. One of the things we want to be able to do is memorize that time scale so we have an idea of when things took place. And just to simply look at some of the major evolutionary changes from the organisms as we go through geologic time. So, first of all, know the geologic timescale. It's one of the major parts of chapters 10 and 11 is coming up with the geologic timescale, how they came up with it, and then knowing the stuff about it. It's divisions based off of what happened during Earth's history. So when you look at it, start down here at the Precambrian, and then as you go up to different eras, periods, and eventually epochs that we'll get to. But this time scale that you're looking at as you go all the way up through those Paleozoic, Mesozoic, Cenozoic, and on, all developed by the geologic events that we talked about last time, starting with relative oldest on the bottom, relative time dating, right? We said that's the law of superposition, the youngest on top. And then if you notice over here, we were able to find areas that had volcanic activity or some type of way that we were able to measure the absolute dating by using half-lives. And that's all down here on this time span. So they kind of have combined both things that we talked about last chapter. First of all, it's broken into 4 different sections: eons, eras, periods, and epochs. Eons are the longest time scale. We'll talk a little bit about not so much the eons, we break it more into the eras and the periods, but eons are longest time scales. And then you break it down into eras. Most of the eras are defined by major life changes that have taken place in organisms that we find. See in there. And as I said, major ones. So we look at Precambrian, pre meaning before, Cambrian meaning life, before life. We do know there's microscopic life that existed in the period, the Precambrian time period. Difference with that is it didn't have hard parts, didn't show much in the fossils that we talked about last week. The Paleozoic era is the age of the trilobites. A lot of times it's considered the age of the fish because it's more of a marine environment. Mesozoic era is the age of the reptiles. And then the Cenozoic era, which is the most recent, is the age of the mammals. So like I said, major evolutionary changes. Then we can break them down into periods, which again is going to focus on major life things, but not such a broad spectrum. Like different periods you could have what type of first jawed fish, the jawless fish. Then you can get into the first time insects were involved. So periods are broken down a little bit more so than what the eras are. And then notice epochs, we only have smallest division of time only in the Cenozoic. And we can break that down as because we know more about that. I mean, think about what you have here in high school. Do you remember what happened this year and last year? You probably have a better recollection of what happened then than when you did in middle school. And then you eventually did in your elementary years. You kind of don't really remember the major stuff. But the more recent stuff, we're able to break down into smaller segments because we know more about it. We are able to see it. And that's the epochs. So eon, era, periods, and epochs. In epochs, you only have to know these that are at the end because we don't really break any of the other ones down into that. If we want to look at now a little bit about each time period to be able to talk about what are some of the major life forms. And we said it's the age of the trilobites in there. And what is a trilobite when you look at it? Well, it's this fossil that we find all throughout the Paleozoic era. And they came in different sizes, different shapes, but the same basic thing. I like to think of it if you lift up a rock and you say, I call them the roly-polies. I know that's probably not their official name, but they curl up. Kind of what a trilobite would look like. Some of them were, small, a couple of centimeters big, and then they actually had some of them as they moved on and evolved to get much bigger and to be a foot big. So they're fairly large structures in organisms that live. We're going to look at one of the things we talked about plate tectonics and how these plates move, we can kind of move them back throughout geologic time too and kind of